Hi guys, today I'm going to look at linear transformations. Now, a transformation is a change, and I want to really explore here how I change S to get to S1. And I'm going to do it by considering the point, instead of saying it's the point 1, 2, I want to say it's the position vector 1, 2. So I've got this point 1, 2, and I want to get to the point 3, 1. So that would be 3 over 1. So that becomes 3 over 1. Now if I was to do the same thing for each point on there, I could say that a point xy would become the point x plus 2 and y minus 1 if I wanted to follow the same rules for each one. And that's what we define as being a transformation. So the transformation of the position vector xy gives us a particular position vector in another place. So there are lots of things that we could do there. Another example of a transformation might be, I'm going to transform xy so that it becomes 2x minus y over x plus y. And that's quite complicated, as you'd expect. Now, something is called a linear transformation. If the transformation of 0, 0 ends up at 0, 0. So when you have a look at the ones we've done so far, if I put 0, 0 into here, I end up with 2 minus 1. So that's not linear. If I put 0, 0 into here, I get 0, 0. So that one is linear. Okay, and it turns out that a linear transformation can always take the form a transformation of xy where we have ax plus by over cx plus dy. And from our previous understanding of matrices, we can see that we've got A, B, C, D times xy. So a linear transformation comes from pre-multiplying by a 2 by 2 matrix. Okay? Now, the way that can help us is that if we had, one of the things we're going to look at later on is something called the unit square. So we make a square just on this axis, just down here. And if we were to think about the points that make it up, we can put them all into one matrix. And that would be 0, 0, 0, 1, 1, 0, and 1, 1. So if I wanted to do a transformation on that, I could do, let's pick a transformation here. Let's go 2, 0, 0, 2 times this big matrix that represents all of the square in one go, considering each of the 4 position vectors all together. So looking at what we know from multiplying matrices, we've got 2 times, so these 2 times those 2, so 2, 0 times 0, 0 is 0, and 0, 2 times 0, 0 is 0. So already we've got that idea that the origin maps onto itself, and then 2, 0 times 0, 1 is 0, and 0, 2 times 0, 1 is 2. And again here we've got 2 on the top and 0 on the bottom, and finally we've got 2 on the top and 2 on the bottom. So that would give you this square here. So this linear transformation is an enlargement scale factor 2. But the important thing is a linear transformation changes the x's and the y's in every position vector in the same way. A linear transformation would be one that would put the origin to itself, and it can usually be written in the form ax plus by and cx plus dy. Now some of them may be 0, so if a was 0, for example, in here, you might just have 2y if b was 2. So you just have to take that into account. So it can be written by this pre-multiplying transformation matrix. And here I've given you an example where I've pre-multiplied all these 4 points all in one go, which is the beauty of matrices. We don't have to do them separately. We can put it all together in one thing, and I've shown that that's how that's enlarged that square. Okay, I think that should be enough of a start and introduction. Thank you.